Let's take a look at the greatest integer function. When we see the square brackets around something, that means the greatest integer that's less than or equal to what's inside of those square brackets. This is different than in interval notation because there's only going to be one number on the inside. So when I look at the square brackets around 5.1, that means the greatest integer that's less than or equal to 5.1, which will be 5. The greatest integer less than or equal to 5.5 is also 5. Greatest integer less than or equal to 5.9999999 is also 5. If we're dealing with a fraction like 1/5, the greatest integer less than or equal to 1/5 is going to be 0. You're going to be tempted to just like take any fraction or any decimal and just cut it right off. But pay attention, especially when you're talking about negative numbers, like the greatest integer less than or equal to negative 5.9. Because if we look at it on a number line and we have 0 here and say this is where negative 5 is, and negative 5.9 will be out here, the next smallest integer is actually right here at negative 6. So when it comes to the negative numbers, the greatest integer less than or equal to negative 5.9 is going to be negative 6. And if we don't have any fractional part or decimal part, the greatest integer that's less than or equal to 5 is going to, again, be 5. So what does the graph of this function look like when we want to graph y is equal to the greatest integer of x? Well, we know that if x is any integer in itself, then that's going to be its value. So if x is 0, then y is 0. If x is 1, then y is 1. If x is 2, y is 2. If x is 3, y is 3. And same thing with the negatives. Now, it looks like it's going to be this nice straight line. However, when we think about what's in between the integers, like a half, what's the greatest integer that's less than or equal to a half? And that'll be 0. The greatest integer less than or equal to 0.9, that'll be 0. And in fact, anything in between 0 and 1, its greatest integer less than or equal to that is going to be 0. Until we get to 1. Then at 1, the greatest integer jumps up to being 1. And at 1.5, the greatest integer is 1. At 1.8, the greatest integer is 1. And so we see that in between 1 and 2, all of those values are going to be 1 until we get to 2. Because at 2, again, it jumps up to being 2. And we see we'll have this pattern that everything in between 2 and 3 will have a greatest integer value of 2 until we get to 3. Because then that value is going to go to 3. This is known as the step function for obvious reasons, but the steps also continue down in the negative direction as well. One thing we've been paying attention to is domain and range. And so let's think about the domain and the range of the greatest integer function. Now, the domain is talking about the set of all the inputs, all the x values that we can use. And no matter what x value we're talking about, it's going to have an integer that is smaller than it. So we are able to use any of the real numbers as part of the domain. However, the only thing that's going to come out of this function is going to be an integer. We're only going to be able to get negative 3, 2, 1, 0, 1, 2, 3, only positive and negative whole numbers. So the range is just the integers.